This is a video on ratios, proportions, and percents. Specifically, how to solve multiple step problems that use ratios, proportions, and percents. This video will focus on percent increase, decrease, and gratuities. So this concept, ratios, proportions, and percents, is so big that I've actually divided it up into 3 different videos. Be on the lookout for a video specific to simple interest, and then one specific for commissions. So this video is just on percent increase and decrease and gratuities. So first thing is setting up these problems. You'll see that I end up using a process like a template that can be used for the most simple problems to the most advanced problems. And step 1 is to write down words to help you keep the numbers straight. So the words are going to be associated with something, whether it's a percent increase or decrease, or maybe a discount, or if it's just a part over the whole. And so when doing a percent problem, you need to assume one of the numbers corresponds to 100%. And then the process we will use is to cross, multiply, and divide. Here's an example of it, where if you're trying to solve for x, you're going to multiply 7 times 3, as you can see here, and then x times 14. So you'll end up with 21 is equal to 14x, and we're trying to solve for x, so we divide. And the answer in this case would be 1.5. So let's bring all this together. So here's the template. So what I said is you always need to have words that correspond to something. In some cases, it just might be a part over the whole or the total. So if you don't know if the numbers are just numbers, then you always still have the part over the whole. And then let's say you want to do something simple like, 2 over 4. 2 is the part, whole is 4. Therefore, you would be solving for the percent. You could cross, multiply, and divide, and hopefully you recognize you would get 50%. Okay, so this is the template that we will use, and I encourage you to use. Remember, I always say you have to bring this. You always have to bring it yourself and bring it to the problem, because they're not going to state 100% anywhere in the problem, most likely, but it will always be one of the 4 things, the way that I teach it at least. Of course, there's a couple ways of doing this. So let's do some examples. So here you can see I already have the template, and for the next examples, I won't use it anymore. But let's get started. What is 30% of 70? So here we're just talking numbers, and so the words that you want are the part over the whole. Okay, you can see we brought 100% here, and that corresponds to the whole. Okay, so sort of the bottom row here is all sort of equal to each other, and the part is up here. And so what we want is, what is 30% of 70? So you will always stack percentages. So here's our percent column, and they give us 30%, so it has to go here. So this makes it nice and easy. You're stacking percents, you've got words over here, and now we need numbers. So the challenge for this problem is, where do we put 70? Does 70 represent the part or the whole? The number 70, not the percent, but the number. And hopefully you hear in here the whole, 70 is the whole. And typically the word of is associated with the whole. And part, they're going to use words like is. So this is what we're trying to solve for. So we're going to cross multiply here, 100 times x, and then we'll multiply here 70 times 30, so equals 70. I'm doing a dot for the multiplication, and you just leave it at 30. You don't have to add the percent. So this becomes 100x. Okay, this is going to be 2100, but let's just prove it to you. 70 times 30, 2100. Okay, all right, so there's 2100, and now you would divide by 100. We've cross multiplied, and here we're dividing. These cancel out. We've isolated x, and that's 2100 divided by 100. We can actually just cut out these 2 zeros, and we get 21. You could put that in a calculator if you need to. 2100 divided by 100 as well. See, the answer is 21. All right, so let's do another one, very simple. Similar, so 25 is what percent of 75? So again, I always encourage the words. I know it seems like a lot to write down, but trust me, working with so many students, this is how you end up solving more difficult problems. So 25 is what percent? So notice we're trying to find what percent. What percent? We don't know that, so that becomes x. And now you need to figure out, is 25 a part or the whole, or is 75 the part or the whole? Hopefully you can see 25 is. Remember up here I said 25 is associated with the word is. So 25 is here, and whole is associated with of. Okay, so 25 over 75, again, cross multiply, then divide. And so we will end up with 25 times 100 is equal to 75x. So this becomes 2,500. Again, put it in a calculator if you need to. Divided by, well, not quite yet. Divided by 75. So now we've cross multiplied. Now we're going to divide by the number that's attached to that x. Since this represents multiplication, 75 times x, we do divided by 75. So let's put that in a calculator. 2,500 divided by 75. And it's 0.3333, which would be represent 33%. It's a third. Okay. All right. So let's do some more word problems. Those are some basic ones. So here is a shirt is on sale for $45, which is $15 off of the original price. What percent discount is the shirt on sale for? Okay, so remember, here's our template. We're going to do words compared to money compared to percent. So I'm giving myself lots of space. And so in this case, what we want is what percent discount compared to the original price. And so we're going to have, I'm going to put discount here. That's sort of the part. And then the original price is like the whole. Okay. And here's kind of our equivalent fractions or our comparisons. Here's where you always put 100%. All right. And there's our template. So now this problem is kind of tricky. Hopefully you can recognize the discount. It says it's $15 off. And it says it's on sale for $45. But notice we don't have sale price. We have discount and we have original price. So we can put 15 here. Okay. Oh, I was thinking percent, and that's just $15. Sorry. What I was going to say is we know right here what percent discount. So this is what we're trying to find. We're trying to find the percent. So what's the original price? Well, we can find it right here when we combine these two. $45, which is $15 off of what it was. So what was it previously? Well, if it's 45 now and you add back the 15, you will see that it's actually going to, the original price was 60. Okay, so now we can cross multiply and divide. So we'll do 15 times 100 equals 60 times x, which just becomes 60x. And 15 times 100, put in a calculator if you need to, or any number times 100, you just add 2 zeros to it. So 1500. And then, so we've cross multiplied. Now we divide. Divide by the number that's attached to the x. So 1500 divided by 60 will tell us the percentage, 25%. And maybe you would have recognized that. But again, it's more about the process. As we get into more difficult problems, you want to have a good process, and that's why I like this template. Okay, so let's do the next one. percent increase or a markup problem. Notice I have a dividing line in here because there's actually two ways of doing this. So I'll do it one way and then I'll show you a different way. So a business owner buys a sofa wholesale for $90. They mark the sofa up to $210. What percent increase does the markup represent? Okay, percent increase. So what we want is the percent increase from the markup. So what you can do here, if we want to find the markup, we have two different prices here. Here we have the wholesale price, and then here we have, this is the sale price. Okay, so the way it works is business owners buy things wholesale, then they mark it up to whatever they're going to sell it for. So those are the words I'm going to use. I'm going to do sale price over wholesale price for our words. And then again, we're comparing money to percents. Oh, geez. Let's have all the... There we go. There's percents. So we know that the wholesale price was 90. And we know that the sale price is 210. And what we want is what percent increase. So we're trying to find the percent. So that becomes X. And 100%, remember, you always bring it to the problem. You always will put it there. Now we can cross multiply and divide. Okay, so this will be 90 times X, or 210 times 100, which again is 210, and then you add these two zeros. So that makes it 21,000 is equal to 90X. So we've cross multiplied, now we divide by 90. Okay, divide each of these divided by 90. Those cancel out, and X is going to be equal to 21,000 divided by 90. So 233.3%. All right. So this represents the percentage relative to the wholesale price. Okay? So what is the percent increase? Well, we started at 100 and it went up to 233. So if we subtract 100 from this, that's the difference, right? Our answer is not 233. Our answer is subtracting 100 from that, because that's where we started. Because we want the percent increase, not the percentage relative to the wholesale price. That's 233. We want the percent increase, which is going to be 133.3%. Okay? That's our answer. That's the percent increase. And these are why these problems are tricky. So could you do this another way? Yes. You could do the markup over the wholesale price. Okay, still comparing money, 2%, and we could put 100 here, as always. Now, wholesale still goes here for $90. But now we have to figure out what the markup is. So what we have to do initially here is we have to take, well, we sold it for 210, and he bought it for 90, so you have to subtract to see what the markup is. Okay, and the markup is $120. Okay, so if you end up doing this and you multiply it, you should get the exact same answer. This is why there's two different reasons for doing this, two different ways of doing this. I like this way better because it's really easy for me to subtract 100 from something. It's a little bit trickier to subtract this up here. It just slightly, it's kind of personal preference. So 90 times X will be 90X. 120 times 100 will be 120. Add the two zeros. Again, put it in a calculator if you need to. Divide it by 90. Divide that by 90. and we'll get X. So we'll have 12,000 divided by 90. Sure enough, we get the same answer. So these are tricky problems. You have to do not only just the cross multiplying and dividing, but you're going to have to do some subtraction to find exactly what they're doing. All right, here is a percent decrease or discount problem. So the problem is you would like to buy a pie that is on sale for 25% off the listed price of $7.25. How much will the pie cost rounded to the nearest penny? So I used our template here twice to just save a little bit of time. And the reason why is because this is another one of those problems that you can actually do it two different ways. And so I'll do it the way that it's actually listed here. And so if we mention up here like the words discount, and then here is like the listed price. And so here we're talking about money. Okay, and so the $7.25 goes here, $7.25. 100%, remember you always have to bring that. And then the 25% will go here. Okay, and then this will be what we're solving for. So let me compare that over here with the other option, right? Well, let me say this actually before I do that. What we will get here is the discount. We will get the amount that you have to subtract from $7.25. Okay, versus over here, if we do what we would call the sale price, so not the discount, but the price that you will actually pay. Again, this will be the listed price. So here's $7.25 again. But now, instead of 25%, if you're not paying 25%, if we're taking, if the listed price is 100% and you're not paying 25%, then that means you are paying 75%. That's the sale. What you're paying is 75% of the listed price. So we'll put 75% here. So hopefully you see the difference. Let's go ahead and solve for both of them. Let me actually do this one first because we've already subtracted over here. So again, what we'll do is we'll cross multiply and then divide. So it'll be 100 times x, which will be 100x. And then 7.25, sorry, my pen is being a little weird here, 7.25 times 75%. So let's put that in the calculator. 7.25 times 75 equals 543.75, and that's equal to 100x. So now we'll divide each side by 100, which is going to give us x. So let's take just this answer. So if you hit divided by, you'll get the a and s, which means the previous answer divided by 100. And you'll see it's going to cost us $5, and let's round up to the nearest penny, $5.44. So that is the sale price. That is our answer, okay? And so I like doing this a little bit better because this is easy subtraction. 100 minus 25 to get 75%. I can do that like easily in my head. Which you'll see over here is a little bit trickier. So we'll still do 100 times x. So we get 100x, and then 7.25 but times 75. So let's do that in the calculator. $7.25 times the 25% discount is going to give us 181.25. And then we divide after we cross multiplied. So let's take that and divide it by 100. And we get the discount. What you're not paying is $1.81. Okay, so now we have to take $7.25 and subtract it. Sorry, pen's being a little weird again. Subtract that $1.81. So let's assume we can use a calculator and just put this in the calculator. Minus 181. And sure enough, we get the same answer, $5.44. So again, for most of these you can choose, which kind of makes it a little bit tricky. So again, I always try to do the subtraction that I can do in my head. So this is the way that I like to do it. But for some students, this is a lot easier. As long as you recognize you're not getting the pie for $1.81, you have to subtract that from the cost or the listed price. Okay, let's do one more. So this is a gratuity or a tip problem. You get lunch at a restaurant and leave a 20% tip of $1.75. What is the price of your lunch before tip? Okay, so what we've got is we have the tip over just the lunch price. Okay, and so what we'll do is we're going to compare money. Here 2%. Let's set up our template. So there's our template. So they mentioned 20% here. So you always stack percents. So you got percent, percent, percent. And then money is over here at $1.75 for the tip. And then what we want is the cost of the lunch. Okay, so again, we'll cross multiply. So this will be 20x. 20 times x is 20x. And then it'll be $1.75 times 100, which is going to be equal to, you just move those decimals to the right 2, which will make this 175. Oh, that's sloppy 7 there. And there's our x. So we'll end up dividing by 20 on each side. And the cost of the lunch will be equal to 175 divided by 20, which is $8.75. Okay, so that answers the first question, but oftentimes with this type of problem on the GED, they'll extend it a little bit. So let's say they're asked, what was the total cost of your bill if you also paid $1.25 in tax? So the lunch we now know was $8.75. The tip, which we found from the previous problem, was $1.75. And the tax, they told us in the second part, is $1.25. So let's add all this together. So $8.75 plus $1.75 plus $1.25 equals $11.75. So just be on the lookout for problems like this where they're actually, I find on the GED, few things are super straightforward. There's always going to be some sort of twist. And so be on the lookout for those twists, and good luck. I hope you enjoyed this video. Please like this video if you found it valuable, and subscribe if you would like to see more videos like these. Visit the link below to passtheged.org to see more videos and learning opportunities that will help you get the highest passing score on the GED. And good luck.